imagine a scenario, right? And I think all of you may have posed in one way or other, right? As a project participant, or in terms, let's say a lot of project happens where group, as a group, you need to submit something, right? There will be people like who will be lagging behind, and there will be people who will like complete their work on time, right? So till now, either as a project participant or a kind of project leader, like where you have taken the responsibility that you will consolidate all the work and submit in the Google Classroom or submit through a kind of printed out document, whatever it is, right? Hope I assume that most of you might not have corporate experience. In case some of you have corporate experience, there also it is again the same thing which is getting reflected here, or the reality which you have here will get reflected in corporate also. Some of your colleagues will be helpful, some of your colleagues will kind of complete their work on time, some of your colleagues, and sometimes you will be one of that person, right? So it is not that society is again combination of all of us. But the point is, when if you remember how we created that critical path method scheduling, so for each of the activity the duration was given, a fixed duration was given, then we started plotting that through a kind of a chart, flow chart kind of thing, try to connect each of them, and then realize that okay, some of the tasks are very critical because the slack time is 0, right? So there isn't any opportunity to slack. Slack means can we delay a little bit? Like we say that today I'm slacking, right? Today I am not doing any work. I'm little bit slacking, right? I'm behind work. So that is how we created that critical path. So critical path are the connection of those activities, right? For each of those activity where slack is 0. That means for each of those activity, there is no possibility of delaying, right? And that is how we found out our critical path and our project durations, right? So if we are able to complete all those critical path activities, that will give rise to our project kind of duration. But that doesn't mean that I'll not complete other activities, or I'll delay, or I'll kind of not focus on other activities. Only meaning of critical path is that out of 100 activities, major focus should be on those 10 or 12 activities, because if there is a single day delay, my project duration is going to get delayed. Other activities, other 90 activities are non-critical. So that doesn't mean that I'll not focus. I'll still focus on them, but little less than the critical activities. If because as a project manager, you'll have limited amount of time, right? So with that, how much focus? So maybe whenever reviewing those non-critical activities, every week you can review those items of what are the starters. But for critical activities, maybe every day in the morning or in the evening, you have to check that whether there is any problem risk associated with those critical activities. So that will help you once you have created the diagram, that will help you to control or manage the project also. It is not only on the planning side, it will help you to manage the project also. But one of the key challenge with critical path method is that we are very sure that somebody has, so how you get that project duration? So just imagine, let's say there is a college function or kind of any kind of event at your home, maybe a wedding is taking place or a anniversary or whatever the, so you are taking that as a project. So there will be various people whose help you will take. So let's say there is a outside caterer who will supply you the food, right, for that evening or for that day. So he has told you, okay, on that particular day, he will be able to supply, or some decoration guy. If there is a marriage in outside, not in your home, maybe somewhere outside. So you have to look through the like all the arrangement, how the like kind of decoration is going on, all those things, right? So somebody says, okay, I'll take 3 days or 2 days or half a day to decorating that pandal or whatever the area you have taken, right? So can you believe in that? Can you complete, or can you create a schedule or create your whatever program you are managing, project you are managing, based on that person's estimate, right? Just imagine like if it is a very big project, 1,000 stakeholders, 10,000 people working on that project, and across different countries people are associated, that becomes very difficult, because when it is a small team, you know each of the individual, you know that okay, yes, if this person is telling me that he will complete within 3 days, so I'll take 3 days. I am very like, he's a trustworthy person, I know him. or if let's say somebody whom you know, he or she might little lag behind the work, you on your own you'll put some buffer time, maybe 1 day, 2 day, right? So that's how the project managers, if for a small project, can manage. But think, imagine if it is a very big project where it is not that every time you know that person. So that is one challenge. When the project complexity, the size increases, the project manager might be remotely located. You will not have control, or you will not have the knowledge about the person's capacity, capability to complete within a due time, right? So that is one challenge. Second challenge is some activities, with all the best intention of a person, some activities time cannot be put in a single time, cannot be put. When I say time cannot be put, I am just telling that a single duration cannot be put. Why it is so? Think about this vaccination development, or think about something where research or the kind of engineering design part is involved, right? Regular work construction, you have carried out this kind of project for last let's say L&T or Tata project, they have been doing it for last 30 or 40 years, right? So they have lot of experience. They know that okay, this is again a highway, this area, they'll do a carry out a soil testing, and they'll come to know that okay, what kind of road construction like kind of progress will happen, right? And they can anticipate that, they can estimate the project duration with a very high certainty probability. But if it is a research and development project, SpaceX is working on different space vehicle launch, ISRO is working on their DRDO is working on their defense projects, right? So in that case, or let's say your vaccinations, which for last 2 years different companies have been working. So for a particular task activity during the vaccination development, putting a single time is very difficult. If I say how much time this cell culture will take place and how much time it will take to test a certain chemical on it, because there are a lot of uncertainties around it, right? It becomes very difficult to kind of put a specific time on a single task or activity. So there in the program evaluation review technique, we call that as an event. For each of these events, putting a single task, sorry, single time, it becomes very difficult. So that is where the like technique is program evaluation review technique, where we say that rather than having a single kind of timeline or a single time for each activity, try to estimate 3 times, right? So when I say 3 different time estimates, one is your optimistic time. So what is the earliest possible, if everything goes well, what is the earliest possible time it will take to complete the project? That is optimistic. Pessimistic is whatever can go wrong is going wrong, right? Then what will be the kind of delayed, like latest time what will take, right? How much, whatever can go wrong, and after that how much time it will take to complete that activity, right? Then realistic time, mostly if somebody goes through the CPM process, what time you would have given, right? So imagine if I ask you to project, I'm asking each one of you how much time you will take to complete this activity or task, right? So you can give a particular day, okay, I'll take 15 days or 1 month time, right? So that is the CPM approach. So in the PERT or the program evaluation review technique, what will I ask? I'll ask, give me your best time. So let's say that you put a lot of effort and everything on track, nothing, let's say, events which is not in your control doesn't happen. So everything goes well. What do you think that whether you'll be able to complete the task within time? So you might say that, okay, maybe 10 days. If everything is well, I have few holidays in between, I'll be able to complete within 10 days. Then I'll ask you what will be the latest, what will be the delayed time. If let's say something happens, something bad happens, something which is not in your control happens, what will be the time you will take, right? So that is the pessimistic time. So in our kind of PERT pot technique, we calculate something called expected time, right? So expected time ET is nothing but my optimistic time plus 4 times of realistic time plus pessimistic time divided by 6. So it is something like a weighted average. Why 6? because we are taking 1 unit of optimistic time, 4 unit of realistic time, 1 unit of pessimistic time, right? So it is something like a weighted average we are taking, and that will give us the mean time or expected time, right? Expected time of that particular task. And for each of these tasks, we will calculate the variance or the standard deviation, right? So that is nothing but your pessimistic time minus optimistic time square divided by 36. So P minus O divided by 6, right? If like kind of take it as a standard deviation, right? So now the challenge is what to do with it. So we in the CPM we used to get some time, and now also for each of the tasks we are getting a expected time. But step doesn't end here. So now the what is the kind of evaluation technique we are going to take, right? So here we take estimate of kind okay. So this part let us cover quickly. So in basically when you kind of plot the kind of PERT diagram, we put it in a circle, cross it, and we put four things: the task ID or the event ID, number, basically what is the event number, what is the earliest date, latest date, and the slack, right? We'll come back to that once we cover the technique. So now, like I said, once we have this expected time, right, or most likely time, right? So expected time is nothing but most likely time. Optimistic time is everything goes well. Pessimistic time is everything goes kind of wrong, right? Whatever can go wrong is going wrong. Now, once you have your calculated expected time for each task, what to do with it, right? It is not the end. So the point of program evaluation review technique, we take a approach of probability. We take a approach that each task or the project completion is not deterministic. It is stochastic or probabilistic. That means it will change directly. I cannot so I cannot say that 100% certainty my project last class what we did 194 days. So that is a very deterministic way of kind of say scheduling. I'll say that I'll take 194 days, but here the approach is little stochastic or probabilistic, where I'm saying for each of the duration which I'm estimating, there is a probability associated with it. So there won't be any duration where I'll say that I'm 100% confident that I'll complete the task within this day, right? So that is the bigger or major philosophical difference of how you approach the evaluation technique. Because imagine where we are kind of using this kind of scheduling, research projects, right? So there would have been a case where we can say that everything goes wrong, right? Vaccination development would not have happened, right? If let's say the actual initial whatever use cases or the experimentation did not go well, then still we would have been at our home, not venturing out because would not have a vaccine, right? So that is the kind of uh, philosophical approach where we say that there might be a possibility, right? Where the project, so because, and that's why I cannot say that okay, on this particular day I'll complete the task within 100% guarantee, right? And that is the way of probability or the approach, probabilistic approach, right? So for that again we take, because for each of the probability or each of the duration it will be difficult, and different tasks are there, it becomes difficult to calculate probability for each of the task and duration, right? So what we use basically, again, if you remember the BRM course, we use something called standard normal table, right? How it is being used. So look at here, look at this diagram. What is our expected time? Expected time is nothing but the mean time, right? Here actually we are calculating the mean. This is the realistic time, most likely time. This is the optimistic time. This is the pessimistic time. Optimistic time plus 4 times realistic or most likely time plus pessimistic time divided by 6. So basically we are calculating the mean time required for that task, right? So in the standard normal table, if you remember, we are all the duration, all the numbers, we are standardizing in such a way that mean becomes 0, right? So what we'll do, anytime any duration has been given to us, any detail has been given to us, we try to convert that into a standard normal table. We try to project that into a standard normal table, and now try to assume or try to calculate what is the kind of probability of completing that task, right? So let us try to understand through an example that will be little easier. Okay. So let's say I have three activities. So three kind of simple activities A, B, C, right? A is will take 2 days optimistically, realistically 4 days, pessimistically 8 days. Similarly, B 3 days, realistically 6.1, pessimistically 11.5. C 4 days, 8 days, 10 days, right? So that is the optimistic, realistic, or pessimistic. The formula is 2 plus 4 times of 4 plus 8 divided by 6, right? So that is your expected time will give rise to 4.33. Then the variance is pessimistic time 8 minus optimistic time 2. 8 minus 2 is 6. Square of that 6 square is 36 divided by 36. So variance is 1. So for each of the activity we are calculating the expected time and the variance time with the formula which I showed in the first slide. Then what how to use that? So at the end, because these are three kind of series kind of activities, right? Or B activity will happen only after A activity, C activity will happen only after completion of B activity, right? So each of them 4.33. So I calculated expected time 4.33, 6.48, and 7.67. If I sum it up, it will give me a mean time or expected time, that is 18.5, right? Close to 18.5. So this 18.5 says my expected time for mean time for completing this project is 18.5, right? And variance also I add this up with a variance 4. That means standard deviation will be how much? 2. So if I go back here, how will I say that? What will be probability of that my expected time? I have expected time of 18.5. What will be probability of completing that my project within 18.5 times? If you look at the right side of the curve, can you estimate that without doing any calculation?
Yes, sir.
How much? What will be the probability of completing this within 18.5 times, right? Because we calculated that if it was a CPM, what would have happened? There is no probability associated with it. We would have just go to our stakeholders, we would have said our project completion time is 18.5, right? Let's say this is the duration which was estimated, right? So if I was taking the CPM approach, I would have gone to the stakeholders and said that, sir, this project will take, there are three activities and each of the expected duration is this much. The project will take 18.5 days, right? Ideally, I should have gone with this 4 plus 6.1, 10.1 plus 8, 18.1 days, right? So again, less than the this whatever we have calculated. I would have gone to my stakeholders and said that 18.1, I'll complete this project as a project manager. I have calculated everything and this project will get completed within 18.1 days. But in the PERT, what we said, no, we'll not take a single estimate. For each of the activity, we'll take three estimates. Then we calculated expected time. Then we calculated the total expected time of the project. Now the question is, because we are telling there is certain probability associated with it. And I said that there won't be any duration where 100% probability. In CPM, there is no probability. That means I have only one estimate. I'll go and say that my project will get completed within 4, 6.18, 10.1 plus 18.1 days. But here what I'm saying, in the PERT approach, PERT approach, each duration is associated with a probability. Then the question is how to calculate that probability. So if I say this is my mean time, because this is the total expected time is the mean time. So this is my mean time calculated for the project, total project, overall project, 18.5 days, and my standard deviation is square root of variance, that is square root of 4 is 2. Looking at this diagram, can I? Yes, Vital.
So I have a doubt.
Yeah.
For the calculation of variance, we took the difference of that 8 and 2, then we squared it. Then how did we calculate that variance in the previous
This
slide?
formula, P minus O square divided by 36.
Okay, sir.
So 8 minus 2 square, 6 square is 36 divided by 6. Sorry, 36 is 1. Similarly, 11.5 minus 3, 8.5, square of that whatever is coming divided by 36. 10 minus 4 6, again 6 square 36 divided by 36 is 1, right? So when I add that up, that will give me the total project variance. If I take a square root of that, that will give me the standard deviation. So I calculated this, and now I'm finding the expected time or the mean time of completion of this total project, overall project, is 18.5 days, and the standard deviation is 2 days. So now my question is, uh, how will I interpret this, right? Obviously we'll do some calculations, but I want you to understand, because sometimes what happens when you get into the calculation mode, it will be like something mugging up, right? You will always try to remember the formula. So hopefully if you're able to understand what this curve means or what does this table means, you need not have to remember the formulas and all those things, right? So what does this kind of standard normal distribution say? This is just a any duration, any number, it has been converted with a mean 0 and standard deviation 1, right? So if you see standard deviation here is 0, these are 1, 2, 3, means any number here is 1 standard deviation away. This is 2 standard deviation away. This is 3 standard deviation away. Similarly, toward the left side, 1 standard deviation less, 2 standard deviation less, 3 standard deviation less, right? So this is how where your TQM Six Sigma concepts come up, right? Now the challenge is, or the understanding what we have to understand without, again, obviously I'll show you the calculation again, but this way it will be easier to comprehend, right? So this standard normal table, what it says, any number you are calculating, right? It will convert mean is 0, right? So mean is 0 here, and the standard deviation is given. So same thing, if I'm projecting the answer, what I got 18.5 and 2 standard deviation to this table, then what does my mean will lie? If I convert my number 18.5, so that is my mean time, right? Expected time is nothing but the mean time for project completion, average time for project completion, right? So if I project this to this curve, then what will be my kind of mean time or the probability? Remember what we discussed in the BRM, or later on also in some of the data analytics tool, you would have gone through it. How to use this table, right? So remember what we discussed, the central limit theorem or the normal distribution, right? If I have different distributions, right? Theoretically, if I say this project can be same activities, right? There are infinite possibilities, right? In a probabilistic scenario, let's say as a project manager, I handle this, as a project manager, you handle this with different team, same set of activities, right? So duration will be different, right? Completion time or the expected time will be different, right? So theoretically, if I have those kind of information, right, and if I start to take a sample out of it, that sampling distribution will give rise to this kind of standard normal distribution with a mean 0, right? And this standard deviation, which is nothing but the project standard deviation, right? Or the population standard deviation. So that is what we discussed in the business research methods. Same thing is applicable here. Theoretically, if I try to kind of, I as a project manager is handling that project, all of you try to handle that project, activity A, B, C. The expected time will be different. When actually you execute the project, expected time, the average time will be different. Now what we are doing, we are plotting that. We are taking sample of those, plotting that infinite possibilities as per the central limit theorem, that will give rise to a standard normal table, standard normal distribution, right? Actually, it will give rise to normal distribution, and we are converting that to a standard normal distribution because it will be easier to read. So in that analogy, if I take my mean time as a mean of the standard normal table, what will the probability associated with it? I hope at least you remember how to read this table. These are nothing but your how much standard deviations, right? And these are the probability, whichever is inside these numbers, right? These are the probabilities, right? I'll just give another 1 minute. We are at 3:05 because I think that is this is the only thing you have to understand, right? If am I clear or any doubt on this? What I'm trying to explain? Why we are moving from the critical path method to this new technique, right? In the critical path method, there is no probability associated with a completion. As if there is, and I am like God and I am complete everything on time, right? Which is very irresponsible, right? Because I'm telling 194 days or 18.5 days. If the same task I was taking as a CPM activity, I would have gone to the stakeholders and said that 18.1, right? So I'm not telling it. We do not use CPM. Most of the project you use CPM, where we to this certain extent. Obviously, there might be natural calamities, some strike, and all those things, which is not in our control, right? But unless those kind of things happen, which will be in the tender document or the construction, whatever the project is going on that document, we know that okay, this activity will take this much time, so we are pretty sure that we'll be able to complete 18.1. But where the projects are or activities or the events are uncertain, we are developing something, some healthcare project or some application, right? We're not sure about the end result, right? So they are estimating a particular time is difficult. So therefore what we have to come with a probabilistic approach, where we say that we are calculating time, but that time comes with a probability, right? And we are now trying to calculate that probability. How to calculate that probability? Whatever number we are getting, so this we are getting as a our mean time, right? Whatever time we got, right? So this is the expected time, this is the mean time, right? Mean time, always remember, for a standard normal table, mean is 0, right? So what does this 0 means? What will be the area to complete this project within 0 standard deviation, right? 0 standard deviation from the mean, that means within the mean time 18.5. So I'll project this 18.5 here. So that's what I have been telling you, right? My mean for a standard, so I'm projecting my project, whatever the project durations, into this standard normal table. So that 18.5 becomes here the mean. What is the mean here? 0. So 18.5 becomes stays here. So what is the duration it will take? That is, I'll come to know from this probability table, 0.5. So this is the area, this up to this, because this is a never ending, this is a till infinite it can go up to. So there is no kind of a intersection here. But if I start taking the area, right, total area is 1, half of the area is 0.5, right? Up to this point, whatever the area, that is 0.5. So what I mean to say is, whenever you are calculating that expected time with certain standard deviation, if somebody asks you what is the probability of completing the project within that mean time which you just calculated, it is not 100%, it is 50%. See the difference of approach in CPM. If I had gone through CPM, I would have told that is my, yes, that is my project time. But now what I'm going to my project stakeholders and saying same duration 18.5, but 50% probability. There is a 50% probability that I'll complete that task or that project within 18.5 days, right? Now if I say what is the okay, you the project stakeholder say 18.5, you calculated and now you're saying it is, it will 50% probability. Okay, let's say I give you another 7 days, right? Another 1 week. Now you give say me 100% guarantee. So 18 point, let's say 6.5 more, so 25 kind of days, right? So even then I cannot say that it is 100% probability. So how will I find out that how much, like what is the probability of completing that project within 25 days? So I have to find out where does this 25 will lie, right? Because 18.5 I'm putting it here in the middle position, which is 0. So how will I know that where does 25 will lie here? So I'll calculate that through that formula, which is nothing but x minus mu, right? X minus mean divided by your standard deviation. So let's say some my project stakeholder says, how much time you like, okay, you are telling 50% is, I'll give you another 1 week, let's say 25.5 or 25 days, right? Now you guarantee that you'll complete within 100%. You give me 100% is guarantee, right? Now also I cannot give. How will I calculate? 25 minus 18.5, that is how much? 6.5, right? 6.5 divided by the standard deviation. Standard deviation, what I had calculated? My variance was 4. Standard deviation will be square root of 4 is 2. 25 minus 18.5 is 6.5 divided by 2, that is 3.25. So here is 3. 3.25 will be around here, right? Around 99.8, let's say 99.87 or 99.875. So now also never you will approve that latest, you can say that 99.90% or something like that, right? If you give me the stakeholders give me 25 days, so what will say? Yes, I'll complete. My guarantee is or my estimate is with 99.87 probability. 99.87% chance is there I'll complete this project within 25 days. So remember, when I say within, it doesn't mean that I'll take 25 days. It might get completed within 14 days also. It might get completed within 18 days. But it will be anyway, it will get over within 25 days, right? So that is the difference, right? Is this clear or any questions how we are calculating that? I'll show you some calculation. Don't worry about that. So average time is 18.5. Standard deviation is 2 in the last slide. What you calculated? Let's say the management or the stakeholders or your customer, they say that I'll give you 21 days. Tell me how much, like what will be your guarantee to me, right? So how will I calculate that? 21 minus 18.5, that is 2.5 divided by standard deviation, that is 1.25. So this is 1.25 far from the mean, right? So you can either calculate in this way or you can just go and find out 1.25. 1.2 is here, right? If I come here 1.2, then I have to go and look at 0.05. So intersection of that, right? 0.05, I'll come down. 1.2, I'll go through horizontally, right? Row wise, I'll go at 1.2 and 0.05, I'll come down. So that I'll reach at 0.8944. So if my customer or the stakeholders gives me 21 days to complete the project, I'm 89.44% certain that I'll complete that project within 21 days. So I'm not telling exactly 21 days. I'm telling within 21 days. It might take 12 days. My like kind of resources or the who are working that project might be excellent people. They might complete it soon. Or it might take 28 days also. So it is not that I'll complete only at 21 days. What I'm telling, the probability of completing within 21 days is 89%. If you give more numbers, let's say 25 days, it goes up to 99%, right? Is this part clear? So without getting into the calculation, just try to visualize this. What we are doing, whatever expected time we are calculating, we are assuming that that is at mean. Mean is 0 here. And let's say if somebody asks you, okay, no, we need to complete within 12 days rather than 18.5, not 12 days, let's say 15 days. Okay. So what will happen? So they are telling something which is less than the mean expected time. That means the probability will be very less. So how will I calculate that? 15 minus 18.5, that is 3.5, right? 3.5 minus divided by 2, that is how much? 1.75. So I'll find out 1.75 here. 1.75 is how much? 0.9591, right? But this is assuming this is the positive deviation, but I'm looking something at a negative deviation, right? So what we have to calculate? 1.75 towards the negative end, right? So how much that will be? Where is this? 1.75 is 0.9599. That means the area of what I'm looking at is 0.4599. That I have to subtract from my mean area, 0.5. 0.5 minus 0.4599. So around, let's say 4% or 3% chance. Just see how that only 15 days, but my probability of completing that within 15 days goes below 5% or 6%, right? Because it will take here the area up to this, right? are you able to get this, or any questions or doubt? So my like kind of why I'm showing you again and again, it is easier to go by this calculation. You just calculate your like, mechanically to go through without getting into the kind of plot. Mechanically, if I just go by the like kind of mugging it up, I'll say that okay, I'll just calculate the through the formula. I'll got 18.5. So if somebody in the question it is given, what is the probability of completing within 21 days or 10 days or 15 days? I'll subtract that number from the expected time. Whatever number I get divided by standard deviation. In this particular case, standard deviation was 2. Once I divide that, whatever standard deviation I get, right, I'll try to see that whether it is right side or left side. If it is in the right side, again, I have to look into the table, which will be in case the question comes in the exam, a table will be given to you. You add that up and you get that result. Mean is always 5%, 50% chance, right? If somebody asks any number, any expected time you get, what is the probability of completing within that expected time? It is 50%, right? Let's say another example we'll try to calculate. So there are different activities. So this is the same example which we did and find out 194 days. Yes, Vital.
So can you please again explain once for the negative part?
Yes, so negative part in this table, negative part is not given, right? In this table, if you see, this is the positive areas which has been given, right? So
Yes,
all
sir.
the area is from 0.5. So there is no negative area which is given. Full standard deviation table is given, then it will be given. Like let me see whether that is there. Now this is also a kind of positive numbers. So what I'm trying to say is that let's say this is my 18.5 is in the mean, right? So that is 0. If somebody says, can you complete this project within 15 days, right? So I know that 15 is left side of 18.5, right? Because 15 is less than 18.5. Imagine the number line. If 18.5 lies at 0, where does 15 will lie? 15 cannot lie to the right side. Right side means numbers greater than 18.5. 15 will lie in the negative side. That means it is less than 18.5. So I have to find out how much standard deviation less than 18.5, right? 15 is, I know the standard deviation is 2, right? So 15 lies where? 15 lies 1 point, how much I calculated? 18.5 minus 15 is 3.5 divided by 2, right? So that is 1.75. So 15 will lie somewhere here in this line which is given here, right? 1.75. So now what is the area? Area is this much. This is the probability. This is the probability. If I look into the left side till this line, which is sorry, this line which is a thin line which is given here. So what I'm trying to say is the probability of completing the project within 15 days is the red area which up to this line with the line where it is xn01 is written, right? Because that is where the 15 will lie, right? In my number line, rather than writing 15, 16, 17, 18, if I convert my 18.5 to 0, where does 15 will lie? 15 will lie here, right? Just let me write down. So if the center line is, sorry, little bit, yeah. So if my center line is 18.5, so now I'm representing this 15 days in my number line. So 15 days will lie here, right? 1.75 standard deviation to left of my mean, right? So now what I have to find out, I have to calculate this area. The area of this red till this line, that will give me the probability. So this is a probability density curve. The area under that curve is the probability of that event happening, right? My question is, if my stakeholder gives only 15 days, what is the probability of completing within 15 days? In this table, all the positive side of the mean area is given above 0.5, right? So left side, nothing has been given. So how to calculate that? Same, you find out what is the area, 1 point, what is that, 1.75 for positive side, 1.75 will come under here, 0.9599. If I come at 0.05 down and go left at right at 1.7, the line where both the kind of horizontal and vertical line crosses, that is 0.9599. Let me just highlight that also. Okay. So this is where my 1.7 plus 0.5, 0.9599. So if it was something, let's say, what will come under 15 days means, let's say 21.5 days or something like that, somebody would have asked, right? Or 3.5 means 22 days, right? If the question was 22 days, so this would have been here 1.75. So, but my question is 15 days, right? So what I'll do, I'll try to find out the area because it is a mirror image. So the area from 0.5 to 1.75 will be how much? 0.9599 minus 0.5. The area will be 0.4599, right? So that means from this line, this small line which is 15 days, represents 15 days, to this like kind of thick line, the total area is 0.4599. I have to find out the area from this negative infinite to this thin line, right? So how will I find out? The total area up to this mean I know 0.5. So I'll subtract that 0.4599 from this 0.5. That will give me this area from negative infinity to this small line, right? So 0.5 is the total area from negative infinity to this thick line. I now calculated the area from this small line to the large line, right? So that how much I calculated? 0.9599 minus 0.5. So how I calculated? So this 0.9599, what it shows, from minus infinity to this 1.75, the up to this area, right? Up to this area where this line is there, the right side line is there, right? So if I want to calculate, I know that the distribution is kind of, it is a mirror image. Left side is a mirror image of right side. So what I'm trying to do, I trying to find out the area between this thick line and this thin line, right? So how will I find out that? 0.9599, which is the right side, minus 0.5, that is the up to mean. So this area is 0.4599. Same area will be reflected in the left side also. That means the area between this thin line and the thick line is 0.4599, right? So if I want to calculate from area between negative infinity to this thin line, I'll subtract from 0.5, 0.5, because from negative infinity to 0, the area is 0.5, right? Then here, like if you see, this is the 0.5, right? Till 0, the area is 0.5. So I'll subtract 0.5 minus 0.4599. So that will give you how much? 0.401.
0.0401.
Right. So that means completing the project within 15 days is 4% probability. It is very less. It is very like small, right? Is this calculation clear or any doubt?
Yes, sir.
So this is the same example what we discussed in the last class, but that we carried out in the CPM method, right? Yes, sir.
Sir, is there any way to calculate project valuation also, sir?
Project valuation in the sense?
Sir, suppose I am a project manager and I want to give the company the whole project valuation, how much cost it will occur to complete the project, and how much the external cost, internal cost, that there is any method for that, sir?
again the same approach. There also you can like kind of manage with this cost management. Also sometimes use this bot technique. But again, cost management. If you remember what we discussed in the first session, right? When you were planning for the project, there is something called a business case. So their project manager should have a high level business case where he's telling what will the total project cost. So unless you have a overall limit, high level kind of estimate about how much project will cost, nobody is going to approve that. So you will not wait for the project planning. So in the project screening, if you remember, there are different screening techniques. One of the screening techniques, what is the project cost? One of the big parameter. So there, what happens in the beginning, it is a high level estimate. Okay, similar project has been of 10 crores or 15 crores. So let's say inflation as last 2 years has been 6%, will increase by 10 or 15%. So we go at this kind of estimate, but very high level estimate with our own experience or kind of a stakeholder, like kind of who is our let's say leader, project management leader. We go to him and try to get that. But in the planning stage, when you are scheduling this, right, parallelly also you are estimating your time. So when you are estimating time, you have to estimate your resource cost, your equipment cost, your capital budget, everything, right? And then you add that up. So that will give you to the total project cost. Now you'll go back and say that, let's say in the initial you were told the project cost will be 15 crore. But now let's say when actually you calculate, when you estimate and calculate, it is coming back to 25 crores, right? So when you go back to your project, let's say leaders, the high top management, they might reject. So no, we will not able to give you 25 crores. But most of the time, because you kind of have handled that kind of project, that much difference doesn't come. But yes, in the project planning stage, when you are kind of carrying out this kind of scheduling, right, how much time my project will take, parallelly also you are doing the costing part, right? We will so there is a chapter or there is a session on project cost management. We will do that exercise. But yes, parallelly you have to do
Okay,
that
sir.
also. So now in this particular case, what has happened, for each of the activity, I have a 3 timeline. In the earlier case, what used to happen for each of the activities, for the A activity, if you remember, that was 90 days. So if I go back and if you go to the previous slide which I had shared, so it was activity A had a fixed time of 90 days. But here what we're telling, there are 3 days, right? 3 specific optimistic days. I'll complete within 76 days, most likely 86 days, pessimistic is 120 days, right? So for each of the activities, we have now calculated the expected time, the mean time. So for one activity, I have shown the calculation, but other activities already calculated. So for the first activity A, right, 76, 86, 120, right? So 76 plus 4 times 86 plus 120 divided by 6, that gives to 90 days. So for activity A, the duration becomes 90 days, which was actually, if you have gone through the CPM, it was 90 days. Then what is the standard deviation? 120 minus 76 by 6. Remember, variance is square of standard deviation. So standard deviation is square root of variance. The formula for variance is what? P minus 0, pessimistic time, minus optimistic time, 120 minus 76, square of that divided by 36, right? If I take a square root, rather than taking a square, I am taking P minus pessimistic minus optimistic divided by 6. Square root of 36 is 6, right? 120 minus 76 by 6 is 7.33. I would have gone the other way around also. I would have got 53.78 and taken the square root of that, right? But remember, for each of the activity, you have to actually calculate sigma square, because when you are adding up, so if I want to calculate the standard deviation of the project, I will calculate variance for each of those activities, and wherever those critical path activities, right, I'll add them up, then take the square root. That will give me the standard deviation. That is a mistake most of the students will do, and I'll show you what I'm talking about. So now in the first step, obviously I calculated the mean time, or the expected time, or the standard deviation or the variance, right? Now last class in the same activity, right, we had calculated the critical path is AFGDJ, which was taking 194 days. Here also we'll add them up. This becomes the mean time. Project variance is, remember, I'm not calculating directly standard deviation. I have the standard deviation also. I can add the standard deviation. No, whenever you are calculating the standard deviation for the project, add the variance. Again repeating, whenever you have to calculate the standard deviation of the project, standard deviation of project duration, not the project, standard deviation of project duration, add the variances of each of those project activities which are on the critical path. Take the square root of that. Don't just simply add the standard deviations, right? Add the variances. So A, F, G, D, J, those are the activities which are in critical path. I'll add them up, it become 85.66. Then take the square root. So that will give me the standard deviation of project duration, 9.255, right? If I was going through the critical path method, somebody would have asked, so this calculation I would not have done. I would have gone to my stakeholders and said that this project will get completed within 194 days, no probability associated. But if let's say this is the same different activities, or let's say kind of research activities where a lot of uncertainties are there. So now what I'll say, this 194, how much probability is this? How much probability associated with 194? What is my estimate, or what is my probabilistic assumption that this project will get completed within 194 days? Anyone? We just discussed so far, right? Just project 194 is your mean time. So mean time, what happens if I project that my mean time to here? My mean is 0 here. 194 becomes 0 here. 0 means 0.5. So whenever you are calculating expected time, that is the mean time, right? So mean time, always mean duration, what you are calculating, the probability of, if I'm going through the PERT approach, program evaluation review technique approach, the probability of completing a project within the expected time or the mean time is 50%. There is a 50% guarantee, because mean, if you see, the area covered is 0.5. Mean is in the standard normal table. Mean is represented as 0. So 194 which I calculated will become 0 here. Now if somebody asks me, I'll go to the question. So again, I can calculate that, but again, not calculation is not required. So that's what I want to avoid, right? Let's say somebody says, okay, my project manager or the stakeholder say, tell me what is the kind of guarantee that it will complete it with 95%. Tell me a date, tell me days, number of days, with which where you can say that with 95% confidence, right? It is the other way to ask the question, right? Rather than the stakeholder or the customer giving me a date, they're telling, okay, you said 194 days and you are only 50% certain, right? 50% is very low number. You again calculate and tell me uh, on which time frame you will be 95% certain. How to calculate that? So this is 0. 95% certain means I have to go and find out that area. Without any calculation, I can go to this table and just find out where this 0.95 lies, right? If I just search here, 0.95 is somewhere between here, 1.65. 0.2, if I go to 1.6, and here under 0.05, it is coming around 0.9505. So it is 1.64 or 1.65, right? Now what I'll say, that is the
96.5.
can you, Abes, can you come again?
So 96.5. After adding 95%, we will get 96.5 days. We will need to get 95%, right? So we have to add, right, 0.6 to achieve 95%.
0.6. Why 0.6?
Yeah. Say, sorry, 1.6. You have shown, right, on 1.6 we are getting 0.95.
Correct,
Yeah.
correct.
So we have to add with that 95 mean number.
Correct. Yes.
Okay.
So actually here, it is a wrong calculation. it should be actually 194 plus 1.65, right? So this is the duration where we are sure that we'll be completing within 95%. We'll keep within one. Actually, let me change this. 1.64 actually it is coming, but I'll take 1.65 which was coming there, right? So can anybody calculate 1.65 into 9.255 quickly? $15.27. $194 plus 15.27 will be how much? 120.9.27, I guess. Okay. The question actually is wrong written here. Okay. So how will I find out this 1.65? Because question is asking on which time frame will be 95% sure to complete the project, right? So I'll go back and find out where this 95 area of 95% lies, right? So I'll go back to this curve. 0.95 lies around 1. If I come back at 1.6, it is something 1.65 I have taken, right? Actually, it is 1.6. So 194 0.17. So 209.17 days. If somebody tells me 209 days or 210 days, then I'll be 95% certain that I'll complete that project within 209 days with 95% probability, right? The probability of completion on 180 days. So it is the same calculation, 180 minus whatever you calculate, 194, right? So now you see it is less than my mean time, right? So probability will always come down below 0.5, right? Because completing the project within 194, it is 50% probability. Now they are asking what is the probability of completing the project within 180 days, right? So how will I find out? 180 minus 194, whatever, 14 divided by 9.225. Where my standard deviation is 9.255, right? So how much it is happening? 180 minus 194, that is 14 divided by 9.225, right? So that is around 1.51, right? So what I'll do, I'll go to the curve, find out what is 1.51. 1.51, right? 0.9345. If it was on the positive side, the area would have been 0.9345. I have to find the same thing in the negative side, right? So how will I do that? I'll subtract this number 0.9345 minus 0.5. How much it is happening? 0.4345. So this, from this area, from the mean area to 1.51, the area is happening, or the probability is happening is 0.4345. Same thing I'll subtract from 0.5. If I subtract 0.5 minus 0.4345, how much it will happen? 0.0655. Everybody is getting how I am calculating this 0.4345, because you will get difficulty whenever I gave this same distribution table and ask you to calculate negative duration, not negative duration, but duration which is less than mean. duration with negative standard deviation. Anybody having any difficulty? Because see, the distribution table is not given from the negative side, right? So I know that the mean line basically makes the curve like kind of a mirror image of each other. So what I'm trying to do, I'm hypothetically calculating 1.51 in the positive side. So I'm trying to find out this area from the 0 to the right side area. So same area is a reflection of the left side. So that area is how much? 0.4345. But I want to find out this area, this left side of this line, right? Which is 180 days, because that is what I'm interested in, because the probability of completing within 180 days. So that how will I calculate? 0.5 total area up to mean minus 0.4345. 0.4355 is the area of mean from mean to the this where 180 is written. Mean is the dotted line. Wherever 180 minus 1.51 is written, that is 0.4345. I have to find the area from negative infinity to this line, right? So that is 6.55%, right? So if somebody reduces the days to 14 days only, right, my probability goes from 50% to 6.55%, right? So what I'll say, if you give me 180 days, I come only 6.5% certain. 210 days, it is simple. So I can just go and find out 1.73, 210 minus 194. How did I find out 1.73? 210 minus 194, that is 16 divided by 9.225, right? Why 9.225? That is my standard deviation, right? So that is okay. No, the question is actually a little interesting. The probability that the completion time is longer than 210 days. It is not asking within 210 days, right? See the read the question. The probability that the completion time longer than 210 days, right? So in that case, what will happen? So I'll simply, if I go to the table, so I'll first find out the like kind of where does 210 lies. So in this kind of standard normal table, if 194 is 0, 210 will become 210 minus 194 divided by standard deviation. 210 minus 194 is 16 divided by standard deviation is 9.255, that is 1.73. So I'll go to the table and find out what is 1.73, right? 1.73 is 0.9582, right? So up to this point, up to 210, the area is 0.9582. So, but the question is the probability that the completion time is longer than 210 days, right? So what will become? Total probability, hypothetical probability is 1. 1 minus 0.9582, right? So that will give me 0.0418, means there is a 4.18% chance that the duration will be greater than 210 days, right? If it was asked in other way around, what is the probability that the project will get completed within 210 days? So I would have just told that area, whatever 95 point, how much it is coming. 1.73 is around 0.958, 0.9582, right? 95%, 95.82%, right? So provide a completion time that has only 1% chance to be exceeded. So we're trying to find out 0.99, right, in the curve. So 0.99 is around 2.33. I can go and find out there also in the table. If you go and find out 2.33, that will give you close to 0.99. So I'll multiply that my standard deviation, and my total duration is 215.56 days. If the stakeholders gives me 215 days, 215.56 days, there is a 99% guarantee that I'll complete the project, right? That means there is a 1% chance that, other way of saying this is, there is a 1% chance that project can get delayed beyond 215.56 days. Okay. How much time we have? Hopefully we are Anyhow, we'll discuss this in the next class. Not next class actually. Next class we'll discuss on the critical chain project management. Maybe after that, right? Because right now we are looking everything in an ideal scenario. But we'll look into the there is just some project activities will be time constraint. There will be some project activity where resource constraint. That means resource won't be available. How to tackle those situations, right? Time constraint means stakeholder says, like in this case, something we read, right? Stakeholders is telling you have to complete within 180 days. So that is a time constraint project. We have to complete within 180 days. Then there are various ways. Can I ask the people to do overtime? Can I increase resources? So we'll look into those kind of scenarios, right? So what I'll suggest, I'll kind of share this slide today. Go through it, try to calculate on your own, but please do ask me in the next class, right? Because this is a very fundamental area which will help you. Some of you have taken analytics also, right? It will help you a lot later on in your career, right? Most of people have difficulty in understanding this. What is the use of standard normal table, right? So try to work out on those examples. In case still any doubt, we can spend 5 or 10 minutes on next class, right? So your yeah. Any last question? I'll close this session. Yeah, best.
Sir, I had a problem. We are into a group 10. We have only 2 members. So I was thinking if you could merge our team with someone else, because we don't have anyone left out.
See, I cannot ask anyone to take you because that will be a little difficult. If on your own you are like some group wants to take, but again, both of you cannot get into one team. You need to get into different teams. But I'm okay. Like if some groups are willing to take you or kind of make you partners in their group.
Okay, sir.
But again,
Sir,
like both of you have to go into different teams. Otherwise, one.
Sir, is it okay if we can represent the project by our own?
Yes, there won't be any issue.
Okay, sir. Thank you, sir.
Excuse me, sir.
Yeah.
For attendance.
Roll number
225.
Okay. Okay, I'm closing this session. What is your roll number?
003.
Okay. 003 225. Okay. Anyone else? Okay, if not, I'm closing this session. Be ready for your quiz. I'll make it live by 3:50. You have 10 minutes to complete the quiz. Okay. Chalo, all the best.